and welcome to our final InventX demonstration. So here we're on CAD, computer-aided design. So as usual, please keep yourself on mute, use the chat function, and the Q&A is available. My name is Ellis Marshall, and I have the pleasure of welcoming Jordan Strachan. So I'll hand over to Jordan.
Hi, good morning. Welcome to the final episode of the InventX computer design demonstration series. So this episode will focus on validating design for manufacture, and we split into two different sections: how simulations can help in the design process, and how to design a more sustainable product. I'm going to first go through simulations to verify a product for a specific use. So here I've designed a small workshop crane. I need to make sure this crane is able to safely lift a maximum load of 250 kilograms. To verify this, I can run a computer-aided analysis simulation. So you've designed the part, and then you can put it through the simulation to get an accurate result on how it would perform in the real world. First, I need to specify what material the crane is made out of. So as you can see, there's a wide variety of material we can choose from. For this, I'm just going to assume the material we used is an alloy steel. So as you can see, there's all these different materials, all the standard engineering materials that we can select. But for this, yes, alloy steel. I then need to indicate where and how the crane is fixed, so the simulation can give us a result based on these simulated forces. In this case, the feet of the crane will be fixed to the floor due to gravity. So I'll be selecting where the crane will actually contact with the environment, which will be these feet. So as stated earlier, I want to make sure this crane can safely hold 250 kilograms. To do this, I can add a load to the point where it'll be acting on the crane. I need to make sure I state which direction the force is acting, or my result will be completely wrong. So I'll be selecting the top plane. The load acts in the z-axis due to gravity and in no other direction, as the crane is not moving and no other external forces acting on it. So I only need to select that. I also want to change the unit from newtons to kilograms, as I'm interested in a mass of 250 kilograms and not the weight in newtons. If I forget to change this, the results will be incorrect. So these arrows represent the load. However, they are pointing upwards, so I need to reverse the direction as the force will be acting downwards. Now I've added all the constraints, I need to create a mesh. The mesh is made of triangles. Each triangle is analyzed when the constraints and forces are applied. This is how we get an accurate result on how a product will act within the real world constraints. The finer the mesh, the more accurate the result will be. However, this will take longer to analyze, and depending on the design, may not require a finer mesh, and may in fact make the result slightly less accurate. For this project, a coarser mesh would be fine due to the simple shapes that make up this model. Now a mesh has been added, the simulation can be run. This will produce 3 different plots where the stress, strain, displacement is acting. The red areas is where the maximum stress, strain, and displacement occurs on the respective plots. So here we're looking at the stress. You can see where the darker red regions are is where the maximum stress is being applied. The plots produced are exaggerated to show how the product would deform. We can change the deformation shape to show what the product would actually look like in the real world when a specific load is added and fixed in a specific way. The factor of safety is something else we can determine. The crane is definitely well above the minimum factor of safety, which will be specified by the manufacturing design. And here we go. This is what it would look like if it deformed in the real world. So as you can see from this, the maximum displacement is negligible, which helps verify that this design would be safe in the real world as it would if it was produced using alloy steel, as it would not deform very much. Again, we can actually see exactly where these maximum stresses are acting and what they actually are, what the actual value is. So each one of these values in this table shows which triangle that stress is acting on. We can do that for stress, displacement, and strain. So it can be seen from the plots that the maximum stress, strain, and displacement occur in the red areas. This shows a designer exactly where the design needs to be modified to improve it. So again, I'm going to just show the exaggerated deformation. This will show if a larger load was applied to it, or if it was made by a different material, this is how it would all break and bend. So we know where the parts that may need to be improved are. As you can see, the maximum stress applied is quite low. And this product would be perfectly fine in this situation. So if we make a few simple changes to the design, such as adding extra support and changing the thickness of the parts, we can reanalyze the product to see if these changes have improved the design or made it weaker. If the mesh is too coarse for the design, the software will not let you analyze it. This makes sure all of our results are always as accurate as possible. So it can be seen that our design changes has actually increased our factor of safety, meaning they have improved the overall design. This means we can put a quantitative value on our designs and redesigns to verify that our redesign is better than the original design. We can prove definitively that one design is better than the other through numbers. So again, I'm going to show you that what this would actually look like if a 250 kilogram load was applied to this in the real world. And as you can see, it doesn't deform much at all. In fact, you cannot see it. The actual displacement is so small that it's not really worth measuring in the real world. And again, factor of safety is very high for this. So it is the design is definitely safe. So we can also change the material to see how it will act. The material we commonly use here at the Aura Innovation Center is nylon. Obviously, this material will not be suitable for this project, but just to show you how it would act within the software, I will be selecting nylon. And we'll have to create a mesh and run again, as this is different variables. So as you can see, the deformation is a lot worse. And from the factor of safety is so small, this would definitely not be safe in a working environment, which is expected because this is a 250 kilogram load on nylon. Why would it pop? Right, so time for some poll and questions if you have any. So here is the poll. How interested are you as a business in computer-aided analysis for design validation? Very interested, maybe interested, not interested.
So brilliant as well, John. Thank you very much. Can you just answer a few questions as well? Like, what other situations can you use this model in? Can any situation? Or...
Well, yes, it doesn't have to be a static model. It could be a moving model. We could even simulate wind, vehicles moving, tides, water. It's for this example, just because I could get as much information as I could in this project as possible. I chose a static model because I can show everything quite simply with that. We can do a lot more complex models with this software.
It is very impressive, I'd say. Yeah. So yeah, again, please do answer the poll. How interested are you as a business in computer-aided design or computer-aided analysis for design validation? And please, if you've got any questions, do ask us on the Q&A section. So we've got a few people very interested and a few maybe interested. And the best bit is we've got no, not interested. So awesome news. Yeah, I'll hand back over to Sean.
Right. So I will now show you how we can verify the sustainability of a component. Here's the outer body for the keyring we've been designing throughout the series. Again, we first need to select the material we'll be making this component out of. Again, a common material we use here is nylon, so that'll be our starting material. So let us select the manufacturing region to Asia and see how sustainable a component would be if we produced it on another continent and transported it here. We will assume this product was injection molded and also set our region of use to Europe, as that's where we're based. I can also specify the lifespan of the product by changing the duration of use. This is a simple keyring, so leaving it as 1 year is reasonable. The end life shows how much material will be recycled, incinerated, or sent to landfill throughout its life cycle, from retaining the raw materials to its eventual end of life. We can now set these factors as our baseline and try to improve the sustainability of the product. This can be accomplished by a manner of techniques. For one, we can change the type of material to another material with similar properties. The tensile strength, for example, does not need to be as high. It would also be preferable if we can make the product cheaper while also improving its sustainability. So we can change all these factors to see if we can find a similar material. We'll then be given the list of materials with similar properties. The one that's jumping out at me is ABS, as it's another material we commonly print here at the Aura Innovation Center. So I'll be applying that to this and comparing it with our baseline. The part was also manufactured in Europe, so this will help improve the sustainability as we're closer in location to where it's being used. So once we've manipulated these variables, I can produce a sustainability report, which compares the baseline we produced earlier with this new version. So here is our sustainability report. It details everything we've selected and all the results we've gathered through our simulations. So it doesn't just have to be one test. We can do quite a few tests in one go to try and work out which material would definitely be best for this, and if slight design iterations may actually help the sustainability, usually by reducing the amount of material we used, increases the sustainability of a product. So we can test the strength of that through our simulations and then put it into the sustainability to make sure it is both safe to use and more sustainable. So these two simulations work hand in hand. So I'm going to go through this in a bit more detail now. This first page shows us all the variables we selected for our redesign. This includes the manufacturing process, the transportation, the use and end of life, and is all broken down into where we selected and what kind of process. This second page, this contains the environmental impact graphs. These graphs can show us the carbon footprint, total energy consumed, air acidification, and water eutrophication caused by a component if it was produced the way we stated earlier. Each graph is broken down into 4 categories: material, manufacturing, transportation, and end of life. So for example, in the carbon footprint chart, we can see that to obtain the raw material just for this one component, in this case, the ABS would emit 0.153 kilograms of carbon dioxide. This next page is just our baseline. This is what we selected for our original version of this project. And on the final page, we compare the values of the baseline with our new design to see exactly how we've improved the sustainability. So as you can see, the ABS has improved quite drastically from the baseline. We can break these results down a bit further to see what parts of the component life cycle is the least sustainable, so we can focus on those areas to modify them to improve the sustainability. So simple changes can help reduce the carbon footprint and all the others. So these results are a great way to estimate how a component will contribute negatively to the environment and shows areas of the design that need changing to increase the sustainability. So right, we're now going into another poll and questions area. So I'll pass on to Ellis Marshall. Do you have any questions?
Thank you very much. So yeah, I'll just read out the poll. So how important to you is adding sustainability as a factor to the design process? So very important, quite important, not important. So what we're talking about there is the graphs that we saw looking at the CO2 equivalents and how that breaks down for your product. You can all estimate that before you've actually built your product. I think that's a very powerful tool for companies to have access to. So we'll go to questions. So a few of these are going back to the previous topic you just talked about. So can you apply other forces other than gravity?
Yes, of course. So we actually did apply a force that wasn't gravity, it was the load, but we can also apply forces in different directions. So imagine a human is pushing a box, for example. We can simulate that force. We can also simulate the wind, as I said earlier, and any other environmental impacts on an object. We can also simulate slopes, frictional forces. We can even simulate torques, moments, any sort of force that is used in the real world, we can simulate within these.
So I've an additional question. This is just my mind. Can you alter gravity on it?
Technically, yes, you can. Yes, you can simulate this on another planet if you would want to.
No, that's awesome. I just love to have it in space and then simulate no gravity. Anyway, we've got another question. Can this process be used to verify the safety of the final product?
Okay, so this process is a great way to verify the design, but you cannot use this as a definitive measurement to determine if your product is safe, especially if you're going to use it in a commercial environment. You have to make sure that product is safe through testing with the actual product when it's been finished, just to ensure everything is perfectly safe. This process is a great way to validate the design, to make sure that we know that this design, yes, is up to scratch and is an improvement over previous designs.
Brilliant. And we've got another question here. It's on the environmental charts.
Right.
How accurate are the environmental impact charts?
Okay, that is an important question. Environmental impact charts, they are accurate. They're as accurate as the variables we enter into them. So the more accurate the variables are we put into this software, the more accurate our result is. We're never going to get 100% accuracy, but we can get pretty close to that. Again, if the more assumptions made, the less accurate the model is, the charts are going to be at the end.
No, that's a great answer for that. So that's all the questions we've had so far. But if you've got any more, please do ask them in the Q&A section, and then we'll just look at the results of the poll. So I think it's quite good. This is a very good result. How important to you is sustainability as a factor to the design process? They've all said very important. And I think it's on a lot of businesses' mind as well to show their sustainability up front and to push their products to be that sustainable product, because consumers are now looking at sustainability and the carbon impact of a product. So yeah, brilliant. So I'll pass back over to Jordan.
Great. So I'm now just going to quickly run through our entire webinar series. Just very quickly, briefly. So we started off with our CAD designs and how we design for 3D printing, how we change aspects of a design quite quickly to help make sure everything fits together, and also to make sure that it is 3D printable. So we added text, making sure that text was the right size. We added different features to the product, making sure those features are big enough to be 3D printed. And we also showed how we can assemble these parts together. So here we are using a different variety of SolidWorks tools. Yes, these are all the tools we use to make more detailed and engineering strong projects. And then we went on to product visualization, where I showed you how we rendered our projects and how we can make those look visually interesting to clients, to anyone that needs to see these products, that needs to see what they would look like as realistic as we can possibly get in an environment that is realistic. So here we have a picture of the keyring we've been designing throughout this series in our workshop. And I showed you how we can send this information to a manufacturer so they can build it. And finally, we moved on to virtual reality and our product visualization webinar, which are all available on YouTube now, which you can go see on our YouTube page. So this is virtual reality, as we stated in that webinar, is a great way to visualize the final product in a way that is as close to real world as possible. So I showed a few different virtual reality models we'd produced. And then finally, we went over today, simulations we can conduct, and also our sustainability and how we can validate the design of a product. Again, this is just the design. If you want to make sure it is safe, you will have to do external test, well, the testing through the final finished product or a prototype. But this is a great way to validate the design in both sustainable and safe way. We can combine these both together if we need to make the product maybe not as strong. We can still validate that it is strong enough for its purpose while also validating that sustainability has improved. So here we are going back through the different information we can get. So it can be seen like a few simple changes can really drastically reduce all of these things. So that has been our May series of our InventX demonstration series. And I just want to big thank you to everyone who has been with us throughout this last month and had enjoyed watching our content. It has been a great experience to just go through all the work we do here and just show it to the world.
No, brilliant. Thank you very much. And yeah, if you've got any questions, please don't hesitate to ask them, or you can email them to us at aic.aura@hull.ac.uk. So please do get in touch with us if you've had any interest in any of the webinars we've done, have any questions, are a small business or a large business who want some services or work doing, please do get in touch. We are open and we are here to help you.
Yeah, and remember, all our videos are available on YouTube if you would like to watch them or rewatch them. So just to catch up on all the things we do here in our InventX space. Thank you all for being here and coming to these webinars and learning about what we do here and how we can help you as a business.
So yeah, if there's no further questions, I think what we'll do is we'll end in a minute, if that's okay. And then we look forward to seeing you on our next series, which is Advanced Materials, coming very soon. And then we've got printed circuit boards. And then after that, we'll be looking at virtual reality. So you've seen a bit of the virtual reality previously through the CAD. And then we'll do some more looking at more interactive designs and all sorts of features going on. So that'll be quite exciting. But yeah, so from myself and everyone behind the scenes, thank you very much. I'd just like to say, Joe and Roz, thank you very much. And Jordan, thank you.
Thank you.
And thank you to our audience. Thank you.
Thank you. Bye.